Let's check out an AP question of the day involving the chain rule and trig functions. So pause the video, see if you can answer it, and then come back for the explanation. So let's look at the derivative here. Exponents, ETA, exponents, trig, angle. So exponent happens first, bring down the 3. Subtract 1 from the exponent, we keep everything else the same. Times, the derivative of cosine is negative sine. That's what a lot of people are going to mess up on. They're going to forget that negative. Times the derivative of the inside, which is 8. So we've got 3 times a negative times 8. So that's negative 24. We can eliminate that answer choice. We can eliminate the first answer choice because it doesn't have sine and cosine. And then the last answer choice we should eliminate because it doesn't have cosine squared. This is our answers right here. Answer with C. Okay, so the next thing we need to talk about is taking the derivative of logarithmic functions. We've talked about polynomials. We've talked about rational functions. We've talked about radical functions. We've talked about trig functions. We've talked about exponential functions. We've talked about almost everything except for logarithmic functions. So let's look at the rules here for the derivatives of logarithms and if we have a base other than e. So they really favor the natural log. Okay, the natural log comes up a lot. So here's the rule for the derivative of the natural log. It's 1 over what's inside the natural log times the derivative of what's inside the natural log. Or you may see this as just u prime over u. The derivative of what's inside the natural log divided by what's inside the natural log. So a lot of times these are going to simplify a lot. Just remember, over here I've got a note, u represents a variable expression. So it could be something like 3x. It could be something more complicated, x squared minus 2x. It could have trig in it, cosine of 5x. You never know, okay? But u is just representing a variable expression. It's not just a single variable. So like I said, they really favor the natural log, but sometimes you'll have a common log or a log with a base of a. Now, where this rule comes from, it comes from change of base. Okay, so if you recall, and I think I'll talk about this later, but we can rewrite the log base a of u as, and actually using natural logs, the natural log of u over the natural log of a. You're probably not used to seeing it with the natural logs. You're probably used to the common log, but it doesn't matter which log you use, it actually ends up being the same thing. So natural log of a down here, that's just a constant. So that's what's going on right here. That's just the constant multiple, and then it's the derivative of the natural log of u prime over u. Okay, so that's where this rule is coming from. It's coming from rewriting that log using change of base, and then the fact that the natural log of a is just a constant, and it's in the denominator, so we got to have 1 over, okay? And then the derivative of natural log of u. And then what if we have an exponential that is not e to the x, okay? What if it's 2 to the x or 5 to the x or something like that? So here's what its derivative looks like. The natural log of a, the natural log of the base, times the exponential. So we still have that idea of it being its own derivative, times the derivative of the exponent. So really this rule applies to e to the u as well, okay? So if we just looked at e to the u, the derivative of e to the u, let's use this rule right here. It's the natural log of the base times the exponential expression times the derivative of the exponent. Well, what is the natural log of e? It's 1 because that says the base, e, to what power is e? That's 1. The natural log of e is 1. So that's why the derivative of e to the u is e to the u times u prime, okay? It's the same rule. It's just the natural log of e simplifies. The natural log of 2 or the natural log of 5 doesn't, okay? So let's apply these rules. Let's take the derivative of the natural log of 2x. So y prime is equal to the derivative of what's in the inside, 2 over what's in the inside. Well, guess what? That simplifies 1 over x. Easy as that. Okay, that's the derivative of the natural log of 2x. Okay, let's make it a little bit more complicated of an inside function. So the derivative of this one is the derivative of what's in the inside. So that's 2x over what's in the inside, x squared plus 1. We can't simplify anything there. That's it. We can combine rules, okay? So here's a product rule, x times the natural log of x. So y prime is equal to the first times the derivative of the second. It's just 1 over x. The derivative of the natural log of x is 1 over x because the derivative of x is 1 and x is what's on the inside. Plus the derivative of the first times the second. So 1 times the natural log of x. What's x times 1 over x? It's 1. Okay, now you can't leave it off. You got to have it because it's 1 plus another expression. Okay, so the derivative of this is 1 plus the natural log of x. All right, here's a little chain rule going on here because the natural log is raised to the third power. So we've got to deal with the power first. So bring down the exponent, keep the inside the same, subtract 1 from the exponent times the derivative of the inside. The derivative of the natural log is 1 over x. So usually you would see this written like this. They would go ahead and just put the whole thing over x. Okay, so really not that bad. Let's look at these exponential functions. Okay, y equals 2 to the x. So y prime is, remember, it's the natural log of the base times the exponential itself times the derivative of the exponent. So in this case, it's just 1. Now, you can't multiply these two numbers right here. You literally just write it natural log of 2 times 2 to the x. And remember, this may come into play later, natural log of 2 is a constant. We leave it in this form because it's a decimal, but that is a constant, so that may come into play later on. Okay, f of x is equal to 2 to the 3x, so f prime of x is the natural log of the base times the exponential itself. The derivative of any exponential is itself times the derivative of the exponent. So you'll see this one rewritten as 3 natural log of 2 times 2 to the 3x. And they may take it a step further. Remember those properties of logarithms? And we're getting ready to go over them here in a minute. But that exponent or that coefficient can become an exponent. So that's equivalent to the natural log of 8. 2 cubed is 8. I don't know whether they'll do that or not. But they may pull out that property of logarithms. Okay, why not combine a log and a trig function? Okay, now this log doesn't have a base, but remember what the base is if there's nothing there. It's base 10. So let's rewrite this using our change of base, the natural log of the cosine of x over the natural log of 10. And then I want to rewrite that natural log of 10 there in the bottom. Okay, I'm going to pull it out because it's just a constant. Okay, it's a constant multiple, so I'm going to pull it out that way. So let's apply our derivative rule. 1 over the natural log of 10 is a constant times the derivative of the natural log is 1 over what's inside the natural log times the derivative of what's inside the natural log. So the derivative of cosine is sine. Now, how can we simplify this? What's sine over cosine? It's tangent. So you will probably see the answer like this. All right, and just because, let's look at one like this, 7 to the x over 2. So just remember, x over 2 is just 1/2 x, okay? It may help you to kind of rewrite it this way. So log of the base, natural log of 7, times the derivative of the exponential is itself times the derivative of what's in the exponent. So the derivative of 1/2 x is 1/2. So if they'll probably clean this up, and that would just be the natural log of 7 times 7 to the, and they would write it how it was originally written, and that's all over 2. Okay, so it's been a while since we've written the equation of a tangent line. That's always going to come up, but the process is still always the same. Anytime they ask you to write the equation of a tangent line, you need the slope and you need the point because you're writing an equation of a line. Slope and a point. Where's the slope come from? The derivative. And then the point, sometimes they just give you the x value, so you'll have to calculate the y value, which in this case, they just give us the x value. So let's start by calculating the y value because we need that, so might as well do it first. So this f of pi is equal to the sine of 8 pi. Now, we don't have 8 pi memorized, but let's think about what it is. If we go all the way around the unit circle, that's 2 pi. If we go all the way around again, that's 4 pi, 6 pi, 8 pi. Really, this is the same as the sine of 0, which is 0. Okay, so there's our y value. Now we need the slope. So to find the slope, we got to have the derivative. So the derivative of sine is cosine. We keep the 8x times the derivative of the inside, which is 8. So we need, that's just the derivative. We need the derivative at pi. So, oh, here we go. Here's 8 pi again. But remember, that's just the cosine of 0. Now, this one's not equal to 0. The cosine of 0 is 1. So our slope is 8. So y minus our y value is 0. Our slope is 8. Our x value was pi. Don't put y minus 0. Just go ahead and write that as y is equal to 8 times x minus pi. Now you can leave the right side in factored form, but if it's minus 0, don't leave that, okay? Don't leave that there. Same thing if it's x minus 0. Don't leave the minus 0. Just go ahead and say that's 8x if that were a 0 instead of a pi. All right, let's look at one with an exponential. Now, it wouldn't let me do a superscript within a superscript, so really this function right here is 2e to the 1 minus x squared, okay? So let's get in a habit of doing this the same way, because some of y'all are messing up these questions on the quiz because I don't think you're doing the problems in the same order every single time, so you're forgetting what is what. So I always start by finding the y value. If they don't give me the y value, I start by finding the y value. So f of 1 is 2e to the 1 minus 1 squared. Well, 1 minus 1 squared is 0. E to the 0 is 1. So my y value is 2. So I have my point. 1, 2. Got the x, got the y. Okay. It doesn't hurt to label it. That's going to help you remember when you get to the end of this problem because sometimes these derivatives get a little lengthy. So now we need the slope. Slope comes from the derivative. So the derivative of this function, 2 is just a constant multiple. Derivative of exponential is itself times the derivative of its exponent, so times negative 2x. Let's clean that up. Negative 4x, we can multiply the 2 and the negative 2x. Negative 4x e to the 1 minus x squared. Now let's take the derivative at 1. That's just the derivative for the curve anywhere. We need it at 1. So let's plug in 1 for x. So we've got negative 4 times 1 is negative 4. Here's that e to the 0 thing again. So our slope is negative 4. So here is our tangent line. Y minus the y value is equal to the slope times x minus the x value. Leave it in point slope form. The majority of the time, if they ask you these questions, they leave it in point slope form. They very rarely put it in slope intercept form. All right, so let's do a little bit of practice.